Great. Hello, again. Welcome to the sort of next lecture um, in the Programming in Python series. We're going to talk about the general structure of a program today. This, while we're going to be doing this in the context of Python. Pretty much every modern programming language works in the same way. So take it with a grain of salt, because what we will be talking about pretty much applies directly to every other programming language that you'll be able to access or might be expected to use in the future. So first things first, we've talked a little bit about sort of the history of programming. We talked about the way some of the very, very old original ways people programmed. And one of the first ways people wrote programs was with what were called punch cards. And I draw this history in because it kind of informs why things are done the way they're done today. So in a punch card reading computer, you would have big long sheets where you could stamp in values to program in functions, enter characters, make the computer add, subtract, divide them. And as these programs became more and more complicated, you can't just put in one little punch card to do something. People would make these big long sheets of stacks of punch cards, and as the machine would read through them, it would sort of march down this sheet of punch card paper and sort of read each thing that it was doing and then move on. There was no what's called parallel computing really at that time. You went down sequentially, and that's kind of a key word, down this little punch card. As our sort of technology got a little better, somebody had the really bright idea to just use a magnetic piece of tape and have something to be able to magnetize this tape and change the magnetic state of it. And in doing that, instead of having to physically punch a piece of paper and feed it through the machine, you could have this piece of tape run through a machine and be read electronically. So you could then store a lot more information and read a lot faster, and even do things like rewrite your piece of tape to do different things. So from there, our computers developed a little bit more. We moved to magnetic hard drives, which are rotating magnetic disks that function actually quite similar to how tape reels worked, where you're changing this magnetic state on this magnetic disk, and you can read it back electronically. Now we are a little bit even more sophisticated on some of those, where you're storing the information in a sort of layered set of magnetic transistors inside of a solid, or yes, not transistors, inside of a little solid state wafer. And so now we've reached how we store and communicate with computers now. But all that is to say, we still, in the sort of vast majority of cases, are referencing, when we program, this sequential step-by-step process that is very powerful and sort of makes sense. Historically, that's where it's from. That's why we do programming the way we do. It's also, when we read something, it's generally how humans function. So that is all that is to say that programs in general are read like you would a book, sort of top to bottom and left to right. Um, and as the compiler steps through your text, it figures out what that string of text means, and sends it over to turn it into some more direct, closer to direct hardware control of the machine. And then it goes on to the next line, figures out what that says, as it adds it to your sort of list of commands, and yada yada yada. If your code ever reaches a point where it can't figure out what it needs to do, this is where you get an error thrown. So this is how the your compiler figures out, when it spits you out an error, what to say, where it is. But that is what's called a compilation error, where your code can't be figured out when it's trying to convert it into sort of more computer language than it originally was. We've at this point moved a lot further past that, and we don't always read things sort of start to finish in code. In fact, that's very rarely how things actually run. So your code is compiled top to bottom, but when it actually runs, you might have a piece of code down here that's running and doing a lot of things, but referring to other places in your original piece of text. So when your compiler goes through and reads all of your code top to bottom, and then runs your code, at which point it can jump all over the place and you can get errors that come from other places in your code. So that's sort of a quick explanation of why, how your code is read in, and why you might get an error from a piece of code that is lower, referring to a part of your code that is higher, even though it is read top to bottom. When it actually gets to the point where it's running, it can refer to all sorts of different places. So knowing that, let's open a new text file. So that we can see how this works in reality. So I have my desktop here. I have the little bit of code that we worked with before. I have a new program here that I created that should be empty. So since I made both of these programs with .py endings, Windows now recognizes them as Python files, and if I just double click them, it will try to run them in Python without asking, which is fine, but let's instead edit it. And in a little bit, we will work on editing with an actual Python IDE. But for now, we'll just use Notepad because it comes with all your Windows computers. Right now, my program has nothing in it. Let's add something. Let's just do, since we've seen this already, let's do a nice print statement. Hello world. So now I save that, and if I run it, this right here will open up a command prompt. It will print the words hello world, and then it will close the command prompt, and you won't really see much of anything. So for something, a little piece of code like this, it makes more sense to open a terminal in the same spot. So that's my desktop. I already opened one up, but if you don't know how to do that, don't remember, if you followed the configuration that I had recommended for Windows in the very first video, you should just be able to right click and do open in terminal, and it will open, and then you will be on your desktop. So from there I can do Python and a program .py. And if you see right here, you'll see that what I mentioned about files being referenced. This // means that it is in the current location in the directory, and we're going to load this Python file. There we go. And it said hello world. So we have a nice file loaded in to Python. If you want to see this going down the list as it's compiling, what we can do is we can just copy this text here, and we can say let's print hello world 3 times. It's actually kind of hard to click with this cursor being so gigantic, but I figured it was good for readability. 2. And you'll see why I'm doing this in a moment. So now we have 4 different print statements in this program, and we can reload it. And as you can see, Python goes down here and goes through all the steps. And as I pointed out, you could just copy and paste this into that Python live environment, but obviously that's not, if you're going to write 1,000 lines of code, you're not just going to write it in the live environment. And you probably wouldn't be able to, because starting to do things like referring back to your previous statements and things gets very hard or impossible if you tried to do it in the live environment. So you stepped through this program, and then it finished and left, or exited the program. But here I will add an intentional typo, put an S in there, and now if I rerun this program, as you can see, Python went down this list. It started running this program. It printed 1, it printed 2, and then it said, uh-oh, I don't know what this is. Boom. It tells me this statement is some name error. I don't know what prints is. And Python is smart enough to say, oh, do you mean print? And I say, yes, I do. I do mean print. And so we can rerun this. Python is kind of interesting in some way. I guess not interesting. Python does this slightly different than some other programming languages would, because Python is what was originally referred to as a scripting language. A older style compiler and an older language would not have started printing these, right? When I ran this program, it printed 1, it printed 2. So it actually did these operations, and then it errored out and gave me this error. That's because Python is actually sort of compiling and running this code line by line. So each line, it's changing into sort of the machine language, and then attempting to do it, then moving on to the next line. An older style language, like things like C and things, don't do this. They would just try to sort of send all of this information down to it, the sort of machine code language, and then it would start running its operations. So if this was a language like C, you would just immediately get an error here saying that, well, it couldn't finish compiling uh, the entire script, and it wouldn't actually start doing these operations. There's some reasons that that's more convenient. There's some reasons that that's less convenient, but that's just kind of the way Python works. If you wanted to make something that was Python code into an executable, where you sort of could send it packaged up nice to somebody else, it would have to fully compile the code like a piece of C code, and we'll work with some code like that maybe later in the semester, but it's mostly beyond the scope of this course. If you're working in a language like C, you have to literally do that as step one. So if you ever try to move to one of those languages, you will have to learn how to fully compile your code and things like that. But with all that being said, this is obviously a very simple looking piece of code. In general, what this is sort of the active area of my code, right? Every line of my code, because it's simple, is an active area. But there are a lot of different other sort of zones in a normal program. I'm going to pull up a picture here that's technically referring to C, but it is true of Python code as well, and it's true of essentially every programming language that I've ever worked in. So there are programming languages that don't follow these format or sort of like pipelines and format standards, but they're not very common. So you can kind of take what I'm about to talk about and apply it to most other programming languages. So in general, a program is sort of grouped up into these general parts. So at the very, very top of a program, you'll usually have some amount of documentation. If you did the Hello World assignment that I had actually put out for like homework, you would find that I asked you to do two things: was to write Hello World, which is one line, but then also to add a nice comment header and make one for yourself. That is me essentially directly sort of pointing at this section right here. If you get into doing some pretty intense, large multi-file programming, it will save you an immense amount of time if you get used to sort of documenting what each little file or script is doing. For this class, I will also be asking you to document really heavily throughout your code with comments, but it's very helpful to summarize right at the start so that when you open a file, you get to see what is this supposed to do, and then you're not wasting time trying to go line by line and figure out what it's doing. The second part here is labeled linking section. This is because this picture is essentially is referring to C program structures. In Python, your linking is usually done outside of your program by Python being sort of clever in its dynamic way of handling sort of references to things. But if you try to make your code all self-contained, there is still usually a linking section at the start. What does this mean? What is the linking section? So documentation is sort of commented out, as we pointed out already. So the compiler just skips it. It's like it doesn't even exist. Linking is the first active part of your code. It's where you're going to, the word kind of explains it, link to anything that needs to be pulled in from outside of your script. In Python, you'll start by importing external libraries. You'll see on like our first or second, or very soon in the course, first things we're going to be pulling in are math libraries so that we can help us do better math faster. But also, if you have like your own little Python scripts that maybe you want to refer to, this is generally where you do that. You're going to tell it as it's going, right when the compiler starts. You're going to say, hey, here's all the things that I need here to run my code. So it's really important. It's labeled essential. If you don't do this and you try to refer to something that's outside of your little script, it's probably not going to figure out what it needs to talk to, and it'll probably fail. The next part here is the definition section. The definition and global declaration sections are sort of combined, interchangeable here. In C, you have a definition that's a little bit different from it doesn't really matter. These are kind of combined into one group though, generally. So you tell the compiler that you need, oh, here's all the things from outside this file that I need. Okay. Then you tell it, hey, these are all the things that are like critically important things, places that I need to store values throughout my program or change, or here with this is in this global definition section, along with sort of global storage, you're also going to tell it if you have repeated tasks that you have to do, which you will define as functions, which we will talk about later. But this is where you're telling the compiler, like, here are things that I need to refer back to. So you're coming down, you're telling, you have documentation, you have what you need from outside of your code, you have very important things that you'll refer to later, and then you get down to the main function. This is where you will be doing the activity, the active part of your program. In my code that I wrote here a moment ago, you're only seeing this last part. This is all my main function. Python, because it works line by line, doesn't always need, you don't need to contain your code in a main function, because it will go through and execute your code without it being inside of one. But it is a good practice to, you'll often see people in Python write a main function and put their code inside of it and then run main. We'll talk about how to do that when we get to functions, but for now, everything you're doing is going to be in this live area. We'll pretty quickly get to, even in this live area though, you will still need to, your use of global functions and variables is still optional, but you will need to link to things. So even though we are working in a little live piece of code here, like we're in a main function, you still need to tell Python, the compiler, if you need an external library, because it's not going to know that on its own. So while this little diagram here was actually, made for C, an old language, it's directly applicable. Pretty much every programming language that you work with is going to function the same way. You're going to have documentation, you're going to have a way to tell your compiler what else it needs, and you're going to do this all in a top to bottom fashion in a file. And if you refer to another file, so if you, in this linking section, if the compiler comes down and says, oh, I need to look at this other Python script over here in the file system, it will go to that file and it will step down it in the same way. It'll go top to bottom. And then when it's done with that one, it'll come back over here and continue down in your code. So when you run into errors, it becomes natural, like second nature over time if you do a lot of programming. But always remember that this is what your execution of code and what your compiler does is it goes top to bottom. So when you run into an error, if you look at the line that you got an error on and you don't see an error, and you're 100% sure you don't see an error, you should start walking back up in your code to try to find maybe there's some problem a few lines up that the compiler didn't quite recognize, and it got a few lines later and then it bugged out. This is really common, but it's also simultaneously probably the most frustrating type of bug in code to get, because the compilers can be really smart, and when we have a bug that they don't recognize and it gets thrown on our shoulders to find, it can be a very, very hard task to figure out. So I can't actually, off the top of my head, think of a way to prompt one of those errors. I'll try to find an example for a different lecture so that I can point them out. But they can, this is where coding becomes something that can get people very angry very fast. That being said, computer froze for a moment there. Now, you should have sort of a basic, from this lecture, you should have kind of a basic understanding of what Python does when you open one of these little script files, and why it does some of those things, both from a historical point of view, but also from like a mechanical one. So that's all for structure of a program. See you all later.